Welcome to this course on problem solving and programming in C. In this lecture, this is a third lecture of the course, and the title of the lecture is Structured Programming Concept. In this lecture, we will learn about what are the basic building blocks of programming, how programs are built using these basic building blocks. The concept of structured programming was coined by E.W. Dijkstra. What it says is any computational problem can be solved using only the below three constructs: sequence, selection, and repetition. What are the sequence statements? Sequence statements include the basic statements: input, how do you read input from the user; output, how do you give output to user; or assignment, how do you change value of variable. Variable is basically um, content holders, data holders. How do you change variable value of variable? And then there is something called function call. Function is a black box which takes some inputs and returns back some output. So how do you by using the function you can, these are the four statements. Initially we will focus on these first three statements only: input, output, assignment. And the later part of the course we will also see these function call. Okay. So basic statements which comes under sequence constructs are input, output, and assignment. And selection. Selection is basically ability to execute a set of statements based on a condition. If the condition is true, a set of statements will be executed. If the condition is false, there may be another set of statements, exclusive set of statements will be executed. The constructs, the sample constructs are if and if-else statements. If and if-else statements. The third type of constructs is repetition statements, which includes constructs like for, while, do, while. These are the constructs which repeatedly execute a set of statements a fixed number of times, or a until a condition is satisfied. It's also about, the programming is all about these three type of constructs and how do we combine them using concepts called stacking and nesting. Stacking and nesting. So any computational problem can be solved using only these three constructs and by intelligently combining them using the concept of stacking and nesting. Let us see these constructs one by one and also see what is stacking, what is nesting. So how do we create a computer program? What are the steps involved in creating a computer program? So the steps in creating a computer program for a computational problem are, first thing is we need to write input output specification. Okay. Input output specification means for this kind of input, this is output. For this input, for this output. So the input output statement specification should cover all the scenarios. All the scenarios. What is for each scenario? What is the input? What is the output? So if we have a input output specification beforehand, so once we write the program, we can test our program using this input output specification. So for each input, you run the program and see whether output is coming correctly or not. If the output is coming correctly for all the input scenarios, we call them test cases. So for each test case, if the output is coming correctly, then we say that the program is correct. And if any test case output is not coming correctly, we say that the test case is failed for the program. So we need to look into the program and rectify the errors so that all the test cases are passed. Writing input output specification is also very important and an important task, because if you do not cover all the scenarios, so and what happens is you write input output specification which is incomplete, then your program may pass for whatever the test cases you have written, But what about the test cases which are not covered? So the program may fail on those test cases. So that is why writing input output specification is very important before even going to the algorithm or program development. The next step is basically create algorithm by using basic building blocks. Basic building blocks are basically the three construct we have seen, the structured programming constructs. We have seen sequence, selection, and repetitive statements. And then translate the algorithm to program. Never write program directly. First, learn to write algorithm. And then you can translate the algorithm to program easily. We will tell you how to do that in efficient manner. So if you are separating out algorithm and program, and once you write the algorithm, translate it to a programming language, you can translate to variety of programming language. If the algorithm, if you are writing using only basic building blocks and structured programming concepts, then translating to any programming language is a easy task. So as I told you, develop the algorithm independent of programming language, any programming language, so that once the algorithm is correct, once you have completed the algorithm, it can be translated to more than one programming language, any programming language as per your need. Someone may translate to C language, someone may translate to Python language, someone may translate to C++. So the translation is an easy process. Developing an algorithm and input output specification is an important and time consuming process. Translating algorithm to programming is easy, right? I will tell you, basically we can maintain a table of algorithm construct and the programming language construct. Just by looking at the table, you can translate the algorithm to program easily. So once you translate the program, you run the program with all the input test cases and then check the output. If there are errors, if the test cases are failed, then what you can do is you can debug the program and rectify the errors. When can you certify that the program is correct? When the program is run successfully and on all the test cases and all the test cases are passed, then we say that the program is correct. This is the algorithm. See, in this course, entire course, we will follow focus on the writing the algorithm. So once you write the algorithm in correct manner and using the basic building blocks only, the programming is about translation only, translating the algorithm to program. So we will also give I will spend some time on how to translate an algorithm to program in future lectures. So this is the basic format of the algorithm. So this is the algorithm, keyword algorithm, and then you will specify the name of the algorithm here. Input will describe the input. If the program takes a positive number, we will write that. The programs takes positive integer number like that. We describe the output. What is the expected output of the algorithm? Then there is a begin statement and end statement. Between these two begin and end statements, we will write the actual statements which are formed using sequence, selection, and repetitive constructs of structured program. Let us see what is the sequence statements. So as I told you, sequence statements include input, output, and assignment statements. The function call concept we will see later. For the time being, we will focus on only three statements. Let us see an example. Write an algorithm to compute sum of two numbers. So what is the algorithm name? Sum of two numbers is the algorithm name. What is it it expects? It expects two numbers A and B. Okay, two numbers A and B. What is the output? It displays the sum of the A and B. So basically it displays A plus B. Okay, there is a begin statement and end statement. So since we are telling that it adds two numbers A and B, obviously we have to read the value for A and value for B. When the program is executed, the program should read value for A and value for B and displays the A plus B. Suppose if user enters 10 and 20, 10 for A and 20 for B, it should display 10 plus 20, which is 30 as the sum of A and B, sum of the two numbers. So obviously we need to read take input for A, variable A, and then these are called variables. A and B are variables. So because why they are variables, their value changes during the execution of the program. For example, if A is entered 10, its value will be 10. If the A's value is entered 20, its value will be 20. Right. So A's value for A is read from the user, and value for the B is read input from the user. And then we are storing C is equal to A plus B. What does it mean? Sum of A and B are computed, and it is stored in a data holder or variable called C. Then output C. Output C means we are asking the algorithm. This is to displace us value of C value. Suppose if A and A is 10 and B is 20, A plus B will be 30. The C data holder C will contain value 30, and the display output will be 30 will be displayed. If you look at the way these statements are executed, first this statement will be executed, followed by this statement, followed by this statement, and followed by this statement. That is why they are executed in this order. That is why these statements are executed in this sequence. That is why they are called sequence statements. Okay, one statement is executed after the another. Here A, B, C are called variables which are used to store or remember data. Okay, so C remembers the value of some of the variables A and B. So they are called, basically they are data holders, or which we, in programming languages we call them variables. Variables basically their value can change during the execution of the algorithm or program. While writing algorithms in general, so many books or many platforms will use input or read or synonymously, or output write as synonymously used. In this course, we will use input for read, taking input from the user, output for taking output to the user or display the output to the user. We'll use these to construct, but in general, you may also see read and write statements for input and output respectively. Selection statement. Execute one or more statements based on a condition. If the condition is true, a set of statements will be executed. If the condition is false, another set of statements will be executed. The example statements are if statement or if else statement. Let us see with an example. The algorithm is write an algorithm to compute maximum of two numbers. Suppose the program should read two numbers from the user and display the maximum of two numbers. Suppose if the user enters 10 and 20, the maximum is 20. If the user enters 40 and 20, the maximum is 40. So the name of the algorithm is max2. Input is two numbers A and B. Output is display maximum of A and B. Begin and end. Inside this, read the input A and input B. See, this is the construct. This is the if selection statement, if else. If A greater than or equal to B, it means that A has a bigger value. Then output A. Otherwise, else means if the condition is true, you are going to execute output A statement. If the else means if the condition is false, A greater than or equal to B false means A less than B, A less than B. In that case, if A less than B, B will be the maximum value, contains the maximum value, so output should be B. Okay. So you see, statements are selected and executed based on the condition A greater than B. Here, the if construct contains only single statement inside the if block and single statement inside the else block. But you will see a situation where more than one statements can be included in the if block or else block. In that case, all those statements part of the if block will be executed if the condition is true. Otherwise, all the statements inside the else block will be executed. Okay. Now, if you see, these are the sequence statements followed by selection statement. So this is called control structure stacking. Sequence statements followed by selection statement. This is called control structure stacking. This is one kind of mechanism to combine the different control structures. Sequence statements followed by selection statement. A sequence statement followed by selection statement followed by some other repetitive statements. This is called control structure stacking. Repetition statement. Repeatedly executing a set of statements a fixed number of times or as long as a condition is satisfied. The example statements are for, while, do while, etc. Example algorithm: display first n natural numbers, 1, 2, 3, and so on, n. Here n will be input. Once user enters a value for a positive integer for n, your program should display n as numbers 1, 2, 3, and so on, n. Let us see the algorithm. This is algorithm to display first n natural numbers. Name of the algorithm: printing numbers. Input a positive integer number n. Output display numbers from 1 to n. Okay. Begin and end statements. There is an input n. So we need to display values from 1 to n. So for the first number we are going to display is 1. That is why I keep a variable or data holder named I, which is initialized to 1. I is 1. So while I less than equal to 2, it means these two statements will be executed as long as I contains value less than equal to n. Suppose if I values n values 10, so this repeated statement will be executed for 10 times with I value as 1, I value as 2, I value as 3, and so on. So initially I value is set to 1. So I suppose for example n, you take n as 10. 1 less than equal to 10, true, it is true. So you will enter the repetitive state block, while block, and then output pi. Output I means i's value. What is the current value of I? 1. 1 will be displayed. And then so suppose for example n is equal to 10. So initial I value is 1. This is called initialization. So since 1 less than equal to 10 is true, so we will output I. I is 1. Then I becomes 2. I value is initially 1. Now it becomes 2. So and then this comes back again for the condition. Is 2 less than equal to 10? True. So output will be 2. So this statement, so then I becomes 3. Is 3 less than equal to 10? Yes. So 3 will be displayed like this. 4 will be displayed, 5 will be displayed, 6 will be displayed, 7 will be displayed, 8 will be displayed, 9 will be displayed. And then after 9, I becomes 10, 10 will be displayed. Then when you display for I equal to 10, I becomes 10 here. When I equal to 10, I value becomes 11. I equal to I plus means 11. I is 11. Is 11 less than equal to 10? No, false. So you will come out of the while loop. So this algorithm will display numbers from 1 to 10. This is called initialization. This is called condition. This is called increment. Okay. A repetitive statement will have 3 blocks. One is initialization, another one is condition, another one is incrementation. So what happens is you are starting with I value 1 and displaying I value, and then in every iteration you are incrementing the I value. So eventually I value will reach n, which is 10, and then once you cross out I value more than 10, you will come out of the repetitive statements. So this goes on like this. Execution goes on like this. Condition is checked. If the condition is true, the statements will be executed, and then again condition will be checked. This is called entry. Okay. This is called entry control. This is also called, while loop is also called entry controlled repetition. Entry controlled repetition. Okay, because the condition is checked before at the entry of the while loop. Okay. Right. So let us write the same algorithm using another repetitive statements called do while loop. Do while, instead of while loop, we are using a do while loop. Input n, initialization I is equal to 1 is initialization. Output I less than I equal to I plus 1, I less than. If you compare the previous statement while loop with do while loop, the condition is checked at the end of the repetitive statements. Okay. Earlier the condition was here. Now the condition is here. So this is do while loop is also called exit controlled repetition. exit control repetition, because the condition is checked at the end of the repetitive statement. So similarly, say I equal to 1, so output I means I1 will be displayed, I equal to I plus 1, 2 will be displayed, 3 will be displayed, and so on, 10 will be displayed. When 10 is displayed, I becomes 11. So I less than equal to 10 is false, so you'll come out of the repetition statement. This is also, the do while loop will also have initialization, increment, and then condition. Only thing is, the while loop is a entry control repetition, do while loop is a exit control repetition. Here is also, you can see control structure stacking, because sequence statements followed by repetitive statement. This is called control structure stack. So these statements, whatever these two statements, repeated n times with values, I values one ranging from 1 to n. There is a another construct, repetitive construct called for. So let us see how to display the first 10 natural numbers using the for repetitive statement. So input n. So you are taking your input from the user, and then for I equal to 1 to n, do output I. So you see here, compared to while loop and do while loop, do while loop have initialization, increment, and condition. But everything is combined. The for loop is combined everything. Okay, there is no initialization, there is no incrementation. The for loop is a compact form of repetitive statements where initialization and incrementation are combined in the construct itself. It says it says that for using the I values from 1, 2, and so on n, for each I value in the range from 1 to n, you execute these statements. So for I equal to 1, the output I will be 1. For I equal to 2, the output will be 2. For I equal to 3, output will be 3, and so on. For I equal to 10, output will be 10. So this initialization, condition, and incrementation are combined, or are part of the construct itself. There is no need of special initialization and incrementation or condition for the for loop. That is why this is a preferred choice when you want to write a repetitive statements. Here also you can see the statements is repeated n times with values, I values ranging from 1 to n. For each value of I in the range 1 to n, the statements inside the for loop will be executed. Here also you can see control structure stacking, because this is a sequence statement. This is sequence statement followed by selection of repeated statements. So one statement after the other. So that is why it is called control structure stacking. So let us also see what is control structure nesting and stacking. So with an example, we'll see, write an algorithm to display odd numbers from 1 to n. Earlier, we were displaying all the natural numbers from 1 to n. Now the problem asks to display only odd numbers from in the range 1 and n. So algorithm name is printing odd numbers. Input is a positive integer number n. Output is display odd numbers from 1 to n. So you are reading n, input n. So what happens if the user enters a negative numbers or 0? So that is an invalid input, because this program expects a positive integer number. Okay, but integer, since by mistake the user can also enter a negative number or 0. What happens? Your program should be responsive to that. So it should display with a proper message saying that input you have entered is invalid. So kindly enter a positive integer number. Like that, some message should be given to the user so that he understands the input requirement of the program, and he enters the correct value. So if the user enters a correct value, the program should display from odd numbers from 1 to n. Okay. So you see here in the earlier case, this construct were missing. Okay. So the takeaway from this algorithm is, it's always a good practice to validate the input which user enters. Then if the input is invalid, you stop the program algorithm immediately. If otherwise you execute the program, execute the algorithm. So if n less than equal to, so what is the value, expected value of n? It is anything greater than or equal to 1. Okay, n should be greater than or equal to 1. So if n less than or equal to 0, it means the output we are displaying invalid input, and stop. We are stopping the algorithm. We are not executing further. If the n less than equal to is false, the control will not come here. When control automatically comes here. Okay. Then what we are saying, we are repeating for I equal to 1 to n do. If I mod 2 equal to 1, it means that I contains an odd number. If this condition is true, we are making output I. For when next I becomes 2, 2 mod 2 is 0, which is not 1, so false. Then when I becomes 3, 1 is displayed initially. Then when I becomes 3, 3 mod 2 equal to 1, 3 will be displayed. When I becomes 5, 5 mod 2 is 1, so 5 will be, and so on like that. Okay, so it will displace only the odd numbers, odd integers in the range 1 and n, including both 1 and n, right? So you see here, this is called control structure stacking. This is control structure stacking because this is sequence statement, and this is selection statement, and this is repetitive statement. This is called control structure stacking, which we have seen previously also. Now you observe this. There is a sequence statement inside the selection statement, and there is a selection statement inside the repetitive statement. This is called control structure nesting. So one control structure is written inside the another control structure is called control structure nesting. Okay. So this is a selection if statement inside for. So this is also nesting. This is selection statement inside if. This is also nesting. Okay. You see here all the statement inside if are written with a space on the left side. All the statements within for are written with a space in the left side, and all the statement within if inside for also written more space, bigger space in the bigger space on the left. This is called indentation. Okay, this is called indentation. This is called indentation. Indentation is very important because if you write all the statements here, you will not be able to know which statements are inside the particular construct. So if you are following this indentation, writing the algorithm with a proper indentation, you will clearly know that okay, these two statements are inside this if statement. Okay, these statements are inside this for, and this statement is inside this if. So the indentation will help you to read and understand the algorithm clearly. So when you write any algorithm, you should follow proper indentation. The same indentation you should carry forward to your programming language also. When you're translating an algorithm to program, you should also follow the same indentation. So next problem, display mathematical 10 tables up to 10 values. I want to display mathematical tables, first 10 mathematical tables up to each table up to 10 rows. So what is the input? Input is nothing. So name of the algorithm is print mathematical tables, nothing, no input, and then it displays 10 mathematical tables up to 10 rows, each table up to 10 rows. So what we need to do? The first thing is I want to display something. 1 into 1 is equal to 1, 1 into 2 equal to 2, 1 into 3 equal to 3, and so on. 1 into 10 equal to 10. If you observe, this 1 is fixed, 1 value is fixed. This is changing. 1, 2, 3, 4, 5. Next time, 2 into 1, and so on, 2 into 10. So this value is fixed, and this is changing. So what we need, so for this purpose, what we need to do is we need to use a nested repetition inside repetition. For I equal to 1 to 10, do. For j equal to 1 to 10, output I star j equal to I star j, output new line. Is what it will print is, see, basically I value is 1. For I value 1, j value 1 to 10 will be executed. So what will happen? I value is 1, j value 1, right? 1 into 1 is equal to 1. Now then j value becomes 2. 1 into 2 is equal to 2. Now j value become 3. 1 into 3 is equal to 3, and so on. J value 1 into 10 equal to 10. Okay. Once this one execution of the one iteration of j value j is over, now it will goes to this one. The I becomes 2. And then the innermost repetitive statements will again be executed from j value equal to 1. So what happens? 2 into 1 equal to 2. 2 into 2 equal to 4, and so on. 2 into 10 equal to 20. Again, I becomes 3, then 3 table will be displayed. I become 4, 4 table will be displayed. So for each I value, one table, mathematical table will be displayed. Okay, this is basically, so it displays I value, multiplicity symbol, J value is equal to product of I and J. This new line, output new line means so that the table in next table entry will be displayed on the next line. Okay. After one table completed also, we will display another table in the next line also. So that table 1, table 2, table 3, they will come in this sequence. Okay. This is also, you can see indentation. This is indentation. And also there is a control structure nesting. One for statement is another inside for statement. Also there is a selection statement inside for. This is also called control structure stack. Sorry, nesting, control structure nesting. Okay, so the program solving is about writing algorithms, and writing algorithms is about writing algorithms for computational problems, and writing algorithms is about using these three constructs called sequence, selection, and repetition. How do we combine them using stacking and nesting is the only key to write algorithms. You write algorithm to solve computational problems. How do you write algorithms? Using the constructs called sequence, selection, repetition, and combine them using stacking and nesting. Okay, using these three constructs only, you write any algorithm. Programming is just about translating the algorithm to a particular programming language, which is very easy. That we will cover that in upcoming lectures. Thank you so much.